Hello everyone, I am Selvi, Assistant Professor, CSE Department, RMD Engineering College. Subject code 22CS201, Data Structure, Theory course with Laboratory Component. Second semester, Unit 4. The subtitle for Unit 4 is Graph. Now we will see what does a graph data structure means. So data structure is generally the way to store and retrieve data in a memory. Then how we are going to store that data. So two types of data structures available: linear data structure, non-linear data structure. Under linear data structure, we have stack, queue, linked list. Under non-linear, we have tree, graph. The biggest disadvantage in tree is when we are traveling in depth of a tree, backtracking of edges and finding the shortest path among the nodes is very difficult. To overcome this, graph data structure is introduced. So the major difference between tree and graph is in tree, even though the nodes are connected, the leaf nodes or the nodes under a branch is not connected to the nodes under another subtree. That is, the interlinking of nodes in a tree is very poor. So graph data structure is introduced where every node can be reached by every other node through different paths. A loop or a cycle is possible in a graph, which is not possible in a tree. So graph data structure is mainly used in computer networks to transfer the packets. Packets means the data packets in the internet. Here you can see each node is each system. So it can be a client or a server. So each system is connected to each other system through a path. And for connecting each, so Tokyo and Sydney is one node. Tokyo is one node and Sydney is one node. There is a connection between Tokyo and Sydney, and the cost for giving this connection is 16. So Tokyo and Sydney will be the node, and the edge, this line will be the edge. So this is how each node is connected to every other node. So even soil can connect it to New York. There is no direct connection between soil and New York, but through this path, through Sydney and Seattle and LA, it can reach New York, or from Seoul, Tokyo, Sydney, Seattle, and New York. So we can graph data structure is majorly used in one of the real-time application like Google Maps or Facebook to find the shortest path to connect a node. Now we will see the graph terminologies used in data structures. So definition of a graph. A graph is a data structure. So it consists of a set of vertices. So we can also call it as nodes, V, and a set of edges where each edge will be connected between two nodes or vertices. So graph G is equal to V comma E, where V is vertices, E is edges. So an edge is a pair of V and W. V is for vertices, V and W, small v and W are the vertices which come under the set of capital V. So here in this diagram, the number of vertices are A, B, C, and D. The edges are A, C. There's an edge between A and C, so that we will write that pair of nodes, and B and C, C and D, B and D. Degree. So degree is the number of edges touching a given vertex. So for A, the number of edges that touching that node A. For A, there is only one edge. So the for node A, the degree is 1. For node B, the number of edges touching node B is 2. The number of edges touching for node C is 3. For node D is 2. Some of the real-time application of a graph or web pages with links, methods in a program that call each other, Google Maps, airline routes, Facebook friend request, course prerequisites, family trees, path through a maze. Path. So, if in a graph, path will be defined as the set of vertices. I mean, a path from a vertex A to B is the sequence of edges that can be started from A to B. For example, I am going to see the path from B to Z. So from B, I can reach Z through X. So the path will be VX, Z. So even also I can follow the path of VW, X and Z, or VU, X, Z, or VWYXZ. So more paths will be available. More than one path will be available between a pair of vertices. So path is the sequence of edges between the pair of vertices. The path length will be the number of edges or the number of vertices are connected in between the connecting pair of vertices. Neighbors or adjacent. So the two vertices connected directly by an edge will be considered as the neighbor or adjacent vertices. Here in this example, V and X are adjacent vertices. V and U are adjacent vertices. V and W are adjacent vertices. X and Z are adjacent vertices. V and Z are not adjacent vertices. Reachable. When we say a vertex A is reachable from B, if there is at least one path exists from A to B. For example, B and Z are reachable. Here, B and X where's a edge. So, we will define the reachable point, for example, V and Y. So V and Y are reachable using VWY path or VXY path. Even Y and Z are reachable through if YWXZ or YWVXZ. So more paths are available. A graph is said to be connected if every vertex is reachable from every other vertex. So you can say a graph is connected if every vertex is reachable to every other vertex. So if you consider U is reachable, I mean U is connected to every other vertex. Here, this graph is a connected graph. You can see every vertex is connected to every other vertex. Then, how we can say there are two types of connections, strongly connected graph and weakly connected graph. When every vertex has an edge to every other vertex, then it is a strongly connected graph. So, if A is connected to B, A is connected to D, A is connected to C. B is connected to A, B is connected to D, B is connected to C. C is connected to A, B, D, and even D is connected to A, B, A, C. So it is a strongly connected graph. cycle. A path that begins and ends at the same node, we can say it as a cycle. For example, the path from V and W, V, X, W, again you can reach V. So this is a example of a cycle. A graph which contains a cycle is known as cyclic graph. A graph does not contain any cycles will called as acyclic graph. An edge directly from a node to itself, that is a self-looping, we will call that one as loop. So many graphs don't allow loops. So it will go to deadlock condition. Weighted graph. So the weight associated with given edge. Some graphs have weighted edges and some are unweighted. Edges in a weighted graph can be thought of as equal weight. Most graphs don't have allow negative weights. So here this is a graph and considering the nodes of a flight locations. So the weights will corresponding to the miles between these cities. Directed graph or digraph, we can say it is a unidirectional. So the edge will represent the directions between the nodes. It can be weighted or unweighted. So we can say here the degree. So the definition of a degree is the number of edges connected to a node. So here you can say it has two types, in degree and out degree. A node, I mean a edge, which is going out from the node will be considered as a out degree. So the edge between A and B is a out degree. And the node between C and A is out degree. A edge that is entering into a node, that will be considered as a in degree. So D and E is an in degree. Then edge will be considered as a in degree. This is an example of a directed graph. Thank you.